Hi and welcome to this video about HTTP with Flowable. I'm Valentin Ziegner, and in this video I'm going to show you how you can do HTTP calls with the service registry in Flowable. Now the service registry is a model which you can model in advance and then basically build into your process, or you can create it while creating the process. There's an abstraction layer between your process and the HTTP task. So the person who is creating the process doesn't necessarily need or need to understand HTTP itself. We are going to do that with Flowable Work. Therefore, I have here Flowable Design, which is the modeling application. I have Flowable Work and also Flowable Control. To actually query something, I also created an HTTP endpoint, which runs on my local host on port 3000. And we execute it, we see that under /items endpoint, it gives us back an object data inside, which then contains a list of multiple elements. Here in this case, up until just one. So we have the laptop in here, and we can add more over there. We have the possibility to also host to this endpoint and specify that we would like to have JSON that allows us to create new things in there. So we can just add a mouse to the list, small animal, for example. And once I post that, it gives us back the record it created, including the ID. And when we then go to the get endpoint and just execute that again, in this case, obviously, we don't need to have a body. We have here the laptop and the mouse inside my response, both data. We also have an additional endpoint items/2, where we can now just query that one single mouse, which we have. Now we are going to integrate at least a few of those endpoints into our model, which we still need to create. Therefore, let's go ahead and create a simple app. So that's the Service Registry test app. And inside there, I am going to model. So that's a process for now. So fetch all items. That's my first process, which I'm going to create. And since for all items we don't need any specification, we can just use here the service registry task and create a new service model. So the service model is basically the model which connects our HTTP service to our process model. So let's call that our items service, since our endpoint provides items, and we can now specify what we would like to do in there. So we have an expression service type, we have a script service type, which allows you to either write Groovy or JavaScript by default, and we also have a REST service type. REST allows us to call HTTP endpoints. Now I'm going to specify here as base URL the host, and since my Flowable environment is running in Docker, I need to call here basically an internal endpoint, which is then calling my host machine where my endpoint runs. For the base URL, we typically just specify the host name, and you can also configure that through, for example, environment variables to ensure that this can be different on different environments. Now, if there would be authentication or authorization, we could specify it over here. We also have the possibility to specify request and response handler, and we can have a shared output mapping in here. So in case, for example, for our case, we have the output mapping, which is name, and that is a string. And then we also have the output you might recall description, which is also a string. And this output mapping works for all endpoints without manually specifying it there. Basically, for each, we can have here, in addition to that, also our ID, which is then type long, for example, since it's a number. Let's let's move the ID to the top, and then we can start building out our different REST endpoints. Now we have a fetch all in here, which basically gets all of them. So that's basically considered from a type a search endpoint, and it goes to the URL/items. So we don't specify the full complete path in here, since we already have that base URL, and that base URL combined with the URL which we have down here is going to be what is executed. Here I can now specify /get, and we can then specify either the output path here or output parameters over here. Now I specified the shared output mapping, which we could apply. However, in this specific case, we have a list of items, so we can't use our shared output mapping at this point. We need to go ahead and specify here that below the data parameter, we are going to have all those items, and there we have then basically either an array or JSON. You can pick either of those two and go ahead and specify them over here. Now let's add that operation, and then we can go ahead in here and say we would like to specify the fetch all here from our service model, and it directly realizes the input and output parameters which we have. For this one right now, I only have an output parameter, so not that much, and we can then specify in here that is going to be saved in my variable items. Let's save that and then publish it, and then we can go to Flowable work and execute that endpoint. That's the only model I have so far, so by default it just suggests me to execute create fetch all items, and when I execute it, we see over here that this was successful. I can now look at Flowable inspect and see in here that I have a JSON inside items where we have laptop, mouse, and so on inside. Just that you are aware of, you can now, for example, go ahead and say you would like to add a user task in here. Here we are going to iterate, for example, in parallel over my items. I am going to call the variable item, and then in there I'm just going ahead and saying the item.name is going to be the name of my task. And with that, I directly see basically that I will have for each of those items one single task. However, since that video here is more about the REST endpoints and less about a multi-instance and those things, I'm not going to continue here. We could now have here potentially a form about each item or assign it also to a specific person. But the quintessence here is basically you can reuse that data or use that data now as any other variable which you have available in Flowable, and just go ahead and basically do something with those. Now, not all time we would like to have basically all of them fetched. Sometimes we also would like to specify parameters when we are fetching information. Now, what I'm going to do now, I create a new process to fetch one item. So in theory, we could integrate it also in our one process, but I also would like to show you that you can reuse models, also service models, across different processes. So in here, I'm basically now going to start with a similar thing. I'm going to call here the service registry. And with the service registry, I pick the same item service which I have, but I'm going to create a new operation. So when I go back here to my service model, I can say I have the fetch one operation, which is basically technically a lookup. And here I'm going to say I go to the item slash, and then I specify ID in here, endpoint, and say that is in addition or also a get endpoint. So we would like to fetch something. We could also say we are doing a put or post here to create new items or update an existing item, but that we are not going to do now, that we can still do later on. We are going to use the shared output mapping for this one, but we still need to have an input parameter, and that is basically our ID, which is for us a number. So I'm going to pick long here, and then we have the ID basically coming from this parameter. So you can use backend expressions in here, as I have done this, but you need to be careful. You can only use what you explicitly specified as input parameter. It doesn't know the entire context of your process or case wherever you are using it. Now, when I go back over here, I have now the fetch one operation, which gives me ID, and then we also have different output variables. For having an ID in here, I still need to go ahead and create a start form. So that is my fetch one start form. In there, I'm going to just ask for a number. So that's basically my ID, which I'm going to use in here. And this ID I can then use at the end in here for the value. So here we can just specify my ID. And then for our output, I'm not going to save the ID since that one we already know, but I'm going to save the name and description in here basically as my two output parameters. I could now simply say I am going to create another task in here with my name. So in this case, I only have one element. That is why it's enough to basically do it like that. Now I can just say I execute fetch one. It asks me here for the ID. I'm going to say one. With that, you see already here, we created a laptop. And that laptop basically is in here. And we also have the description as a variable saved here as well. The ID is coming from my initial form. Now, the next question is, what is going to happen when something is going wrong? And there are different kind of errors which can happen when we are using HTTP, and we can also handle status codes differently. So until now, we received just a 200 status code, but for example, that element also could not be found. And in this case, we would like to specify what is happening, and that we can do here by providing handle status codes. Either you can go ahead and just specify, for example, one specific code here, or you can also say you would like to have a collection of codes, and that you can use by using X as a wildcard. So when I say for handle status code for XX, it is going ahead and allowing all the different 400 codes, and they all will be handled. Now, handled means that we need to have an error boundary event, and that error boundary event we can basically place over here on our service registry task, and then specify in addition to that here the error variable name, where we are going to have more information about our error, and we can draw also an additional sequence flow with example here error, and then I can simply place in here my error variable name that I see basically the error directly in the task. Now, what you would like to do if you show a user task with the error here or something else, that is completely up to you, and that also depends a little bit on your use case. So there's not just because I have a user task in here, the need that you always have a user task. Now, when I say now fetch one and I enter the ID 3, which doesn't exist, we see here that we have a service 404, which is coming back to just double check that the 404 is what we expect. We can also execute it over here, and you see basically it gives us back the status code 404, not found, which completely makes sense. Now I created just for fun another endpoint, which is 42. And when we go for 42, we don't receive a 404, which is also the case here, we receive a 500 internal server error. So something is wrong for 42 with our server. And here, often in the business cases, you wouldn't like to handle that in your business process. When something is going wrong with your server, you would like to handle it differently. And therefore, we can go ahead and say, in case it's a 500 and a server error, we are going to fail. So I can specify 5xx in here. And with 5xx, it is basically going ahead and then failing for this specific status code. Now let's say I'm creating a new one, and this time I am going to say my ID is 42. And we see over here that we now see that there's an error message. Now, here it really depends if we would like to expose that error to the user, or if we would like to have some technical in the background that we can see those and monitor those to see that we can eventually retry that. And when you do it in the background, you interrupt basically your transaction. And in Flowable, we can do that with the so-called asynchronous execution. Asynchronous doesn't mean that this HTTP call is happening in the background and we directly continue to the next task. It means basically that we are going to just stop the execution here, persist everything to the database what the user entered, and then in a new thread, we are going to continue the execution of our process. And that has the advantage that we are not going to roll back what happened before. For me, that's honestly not that much, except that the user entered something. It just means that we are going ahead and basically persisting the thing which the user entered. And then you see here basically that nothing happens, since in the background now the error is happening. When you would like to see something about the error, then you can look at the jobs, and there are executable jobs, and it's going ahead and trying that job now 3 times. We might see it here in the timer jobs. There you actually see that we have here the status 500, which is coming back from our execution. And eventually, after a few tries, it will then end up in our dead letter jobs. And there you see actually perfect timing, since here we have now our dead letter job, which we can manually retry here now as soon as we have our server issue resolved. I'm not going to resolve that issue now, but you also need to be aware of that those dead letter jobs, they might grow over time. And when you don't monitor them, you might not even realize that they are happening. So I always recommend to monitor those dead letter jobs. There are REST APIs, for example, available to do that. Now, just that we see also how it works when we now say fetch 1 with 2, we see actually over here, and there I was lucky that we directly see also the task over here. But when you have that asynchronous in there, it's also not guaranteed that the user directly sees the task which belongs to it, which is fine anyway when the task is for somebody else, but the user might be confused in case the user is the person who is supposed to do that task. So in this case, you might not want to use the asynchronous flag and directly show the task to the user. Maybe as a last step, we can also go ahead and say we are going to create a new item. So let's create item process. And in that create item process, I now need to capture more information. So that's my create item form, which I would like to have, where we are going to enter my name or my item. Let's call it item name, since it's not my name at the end. And then maybe also the item description. And in there we have now the data which we would like to save. That is on our start form. I'm going ahead and adding now a service registry task, which is persisting it to my REST service. And here I'm going to use the item service, where again, I need to add an new operation, add new. And here we are going to say type is create. The type is not that important actually when we are using a service registry alone. It's more important when we are going ahead and using it together with data objects. We can now say that is going to be type post. We can say we have input parameters, and one of them is name. It's a string. We can make it required. And then another one that is going to be our description. It's also a string, so we are fine here. The output parameters we could define. By the way, you can also specify here request and response handlers with JavaScript or Groovy or an expression in here, or we can just use the output parameters from up here. So we don't need to define anything there. I just say add operation and then save, and then I can go back over here and say add new, and I can define now here that is no, it's not my, it's item name. There we can also see the variable which is suggested, and item description. With that, it's supposed to be saved. We can do the same error handling here as we have done it for the get before. I am not going to do that now. I'm just going ahead and creating the variable item ID in here, which is the variable we would like to save as a result, that we can use it then later on. And when I create now a new create item, I can have here the keyboard. This is typing now. And once I submit that, we see in here the item ID is 3, and it's keyboard, and that is whatever I entered. And now when I say I would like to, for example, fetch all items, I see that in addition to laptop mouse, I now also have keyboard. I hope this was a good overview for you how you can use REST and HTTP with Flowable. The service registry is only one of 3 possibilities, so you can also use the HTTP task, or you can use data objects. Please look out for an additional video around data objects, which will come soon as well. Thank you for watching, and see you next time.